Welcome everyone to another episode of Further Comments. Damien, hello, good to see you.
Hey, good to see you, Horace, and also good to see our friend Jason. Hey, hello, Jason.
Hello.
Hello, Jason. Now, Jason, I think a lot of people in the industry know who you are. For those of you who don't know who you are, Damien, you wrote an incredible intro, and I'm going to hand it over to you to do the intro for Jason.
I would say that Jason is one of the most thoughtful and really deepest thinking on how lawyers and engineers could be able to change the world because he is both a lawyer and an engineer. One of the most insightful things that Jason ever said that keeps sticking in my brain is that lawyers and engineers are similar, but they are dissimilar in that engineers say, hey, here are disparate things. Here's how I can clump them together. But lawyers, here are disparate things, and here's how my thing is different. So anyway, those kinds of insights are the things that come out of Jason's mouth frequently, which is why I'm so thrilled that he's joining us for the podcast today. So Jason, thank you so much for joining us.
I'm delighted to be here. I got to admit, I am very intimidated. I've been listening and I'm a little worried. Like, can I keep up? Do I have something to offer? But I'm just going to try to live in that discomfort and just let's go.
And we're going to run together.
Look, it's the magic of post-production. When we record, we really sound very dumb, but afterwards we cut it together so it sounds smart. I'm going to give us the kickoff for the topic today because I think this is a hot topic, at least has been for the last 2 months and probably will be for the next 4 months. And that's the topic of AI agents. I think part of it is this is a really cool technology and it can do things that most of us have not yet properly fleshed out or maybe even imagined. And part of it is hype. There is a lot of hype around AI agents at the moment. And when we talk about AI agents, I might set us off by kind of framing the 4 different things that we're actually talking about. The first is from a pure engineering perspective, AI agents being large language models capable of performing actions. Then there is the AI agents as products, which is, I think, where the fuzziness comes in, and we'll talk a little bit more about that. AI agents as the legal concept of a software that can bind a person, which Desert Greenwood wrote about the other day. And finally, AI agents as this philosophical concept of something that has agency and initiative, which is the kind of holy grail AGI, if you like. Well, maybe not even AGI, but just kind of like some sort of intelligence that has agency. And because of that sort of muddied conversations and overlapping definitions, the market is really confused when we talk about AI agents. And I'm going to start by asking Damien, what do you think? What have you heard? And then maybe we'll go to Jason.
Yes, I really love your crafting of the 4 types of agents because I think words are ambiguous. And this a lot of what lawyers do are disambiguating otherwise ambiguous concepts. So Horace, I love how you just disambiguated the word agent. And I would say that any one person that hears the word agent will attribute their one of the 4 taxonomies of agent that you just laid out. So that's why we often speak past each other and being able to say, our agents are autonomous robots that are going to guide us to utopia by doing their own things and by binding us legally, and they kind of conflate all of those aspects. And so that's why I'm really thrilled about digging deeper into the 4 taxonomical items of agents and thinking about how Jason is thinking about these things too. Jason, what do you think?
I think that framing is very powerful, and inherently what it does is it projects the bias that we all bring to a problem or an opportunity, right? Like that's a really good way to observe that, and then we can interrogate it, and then we can hopefully switch kind of our perspective and then move into those others. But I'll be honest, the 4th one, the concept of kind of agency and initiation, for me, that feels like a through line that cuts through many of the other things. And I think it speaks to something that is very, that humans have an intuition about, right? Because we move through the world with agency, we're trying to get things done. And so my presumption is that when we're talking to, kind of a normal person, that's probably the kind of framing that they're coming at this with. And when we use our nerd words of things like products, which I love, it often doesn't resonate. And so if you are a maker and you're trying to bring something into market that has value, it's probably good to anchor on that least common denominator as a starting place. And so I really like what you just projected. And I think you offered people who are going to try to operate in this space a very powerful tool for effectively creating almost like a psychographic profile of who am I engaging with and what's their starting place and how can I get to a place of shared understanding faster.
I would agree that, and I would also add that the number four often is this agent that's going through the world and doing work autonomously, kind of equates to what a lot of people think of AI as magic. So the
Mm.
AI is just magic that does the thing. An agent is just magic that figures out all the things that need to be done and just does that. And so I think that we as humans are tend toward magical thinking, whether it's through AI or through agents. And so I think that you're right, Jason. This is the through line that people see agents either as taking us to our utopian future or a dystopian future where it just mucks everything up. So we need to avoid these magical thinking and really dig into the first three to be able to think through what does this actually mean.
Can I tell you a joke that's not a joke? I guess I'm going to.
Oh, please, please. We love jokes.
Okay. And I may have told this to Damien before, but what is a lawyer's favorite application?
What is it?
It's a secretary. It is somebody who observes work, and when there is adequate signal that is inferred from the work to go do a thing, they go off. They do it asynchronously with the least amount of oversight possible. The secretary also performs another function. They tend to be an interface layer between a whole bunch of variegated tools that a lawyer doesn't want to understand or deal with. And so I observed in many years that, especially in the law firms, we would layer in these technologies and these experiences. And then what would happen is attorneys would hire people to be the boundary layer between themselves and these tools because they were complex and they were hard to understand and the like. But the other thing that, they really appreciated was this was somebody who understood their work patterns, their habits, who they could trust and could literally augment them by going and effectuating their will asynchronously and only coming back for information that was strictly needed. And so it's a joke, but I think maybe it's not a joke.
I love that. And Horace, I'd love to hear your thoughts on elucidating how smart you are with the four taxonomical items. Horace, what your thoughts on what Jason and I just provided?
There's an expectation that mass media, movies, TV shows have set for people. Your everyday person thinks about the Jetsons or a humanoid robot who will understand precisely what you mean, go away and do things, and then come back having achieved the task. And a lot of things that people are selling at the moment kind of claim to go almost as far as that. And we all know, all three of us being builders, it doesn't work like magic. There's a lot of finessing that has to happen in between, but the gap between what people have been trained almost to expect versus what the technology is capable of, and I think that's where the marketing and the hype is trying to bridge that gap at the moment. While these are four different definitions of agents, I think they all fall within a capability spectrum of, I'll come to this concept later, of what I'm calling the complexity pyramid, where the really simple routine tasks are at the bottom and the really expert tasks that only the smartest, like 2% of people can do, are at the very top. And agents and AI is kind of chipping away at the bottom of this pyramid, and kind of clawing its way up. Let's move on to talk about the matrix. We had some emails before this call, and Jason introduced like 50 new concepts, which I'm not sure we're going to have time to cover them all. But this was a really cool idea about the long tail and what people can achieve. So, Jason, Damien, who wants to give an intro to this part?
I'll introduce Jason, and Jason's really been thinking a lot about the Rumsfeld matrix in a way that I think is really applicable to legal. So I will essentially toss it over to Jason to have us think through. For those who aren't familiar with the Rumsfeld matrix, Jason, tell them what that is.
Yeah. So I had a conversation with JM years ago where we ended up going pretty deep on the Rumsfeld matrix, and credit to her. So Donald Rumsfeld, when he was, I think he was Secretary of Defense, he kind of casually mentioned in this briefing how they thought about different types of uncertainty. And what he, and I think people kind of pilloried him for it a little bit, but it was actually quite useful. And what he was really getting at is, imagine that you wanted to reduce your kind of uncertainty into two distinct dimensions. One is, do we know this even exists? And then the other is, do we know what to do about it? And so he referred to it as known knowns, unknown knowns, known unknowns, and unknown unknowns. And I think people were a little bit confused by it, but it's actually fairly elegant if you kind of project it out in that kind of two-dimensional space, because what it's really getting at is it's almost like there's a frontier that you're exploring, right? And you start off in kind of known space, which is I know that a thing exists and I know what to do about it. And then as you start, kind of moving in the basically the latent problem space. Sorry, I should stop using jargon. If you start thinking about like all the things that could be, right? In one direction, you start moving to kind of the known unknowns, which is basically like if I'm on a map, I start traversing, and then all of a sudden it's a little bit it's kind of murky out there. But if I keep looking, then I can kind of reduce that and have more certainty on what's going to happen. And similarly, the unknown knowns, those are kind of the intuitive realm, right? Where it's almost like there's like many of the laws of nature. We kind of know they exist, but we don't know how they work. But we can still manipulate them, right? Like we still manage to, even if like gravity is it a wave, is it a particle? Who knows? We still manage to stick to the ground and move through our day, despite not having a rigorous sense of that. And then ultimately, you start converging on kind of the unknown unknowns, which is really the things that we haven't imagined, right? We don't really know they exist. We don't know what they are. And to get there, often you literally have to just start imagining things with kind of an open space. And I think one of the things that's interesting to consider about this as we're considering the world of agents is how much of the application of machine intelligence is being applied to what I would call the interpolative space, which is things we know. I mean, but like, and to say like we haven't done everything, but it's effectively a version of all the things we've seen before. And a lot of the LLMs, effectively, what they're doing is they're exploring the interpolative space. There's a whole bunch of training data that's been pumped into them, and then you throw some more tokens in, and it predicts. But it's mostly operating within that interpolated space. But as you start moving out to the frontier, you start getting into the extrapolative space, right? Which is things that haven't necessarily been considered before or reduced to some kind of content that is observable. And so that's why I realize this is incredibly abstract and people are probably like turning off your podcast, and I apologize for that. But as a thinking framework and a construct, I think it's useful to really consider for the work that you're doing, for the things you're trying to accomplish, what kind of space are you operating in and where are you trying to pursue? Because that probably suggests how you should be thinking about the application of machine intelligence and agents as support mechanisms that augment human intellect. Okay, that was a lot, so I'm going to just stop.
I really like that, and we're sharing on the screen, and we'll show this for those of us watching on YouTube, that there are known knowns on the top right quadrant to be able to say that these are the things that lawyers know already. These are the things that I don't need my secretary to be able to do. These are the things that I've really figured out and are going to happen. But then I also, as a lawyer, know that I don't know a lot of things like how to be able to put this item into this legal tool. I'm going to have my secretary do that. So I know that, yes, hey, secretary, why don't you go ahead and put this data into that tool? That is a known unknown that I just don't know how to do it. She does, so she's going to do this. And then, of course, on the unknown knowns, there are some things that maybe I want my secretary to go out and be able to explore the space and be able to do this kind of legalish work, but maybe I don't trust my secretary so much. So this is kind of the idea that we want to maybe explore the unknown knowns, and then there are unknown unknowns where, gosh, I don't know if I fear to tread this way, and I don't know. I certainly don't want my secretary to tread this way because that can muck a lot of things up. So that unknown unknowns, there be dragons. So you want to really avoid that. So really, as we think about replacing the word secretary with agent, there are some things that we can be able to have known knowns. Let's just say, let's go ahead and make the known knowns programmatic. That make it deterministic, code it up. Because I, as a lawyer, know every time I do a complaint, I want to be able to say, what are the claims? What are the defenses to those claims? Who are the parties? Like there are known knowns that I want to do this for. Same thing for contracts. I want to be able to know what are the definitions, what are some risks in those things. There are known things that I always want to do. But then we start going to unknown knowns and the unknown unknowns and the known unknowns. We have to decide, are we going to code those up with a human deterministic way, or are you going to let the agent do that in a probabilistic way and explore the space? And there be dragons, because that's the same thing that we maybe don't trust our secretary to do. Maybe we don't trust our large language models to do. Thoughts on that?
I'm going to map all of this back to legal work, because for those lawyers who are listening, they're probably listening to just going, what work does that mean? So I think the known knowns, the green quadrant, are all the work that you as a senior lawyer might delegate to a junior lawyer and go, you have to do a due diligence of these 10 issues on these 20 documents. Very simple, very straightforward, very repetitive. You can build a machine to automate that. The unknown knowns and the known unknowns are probably two types of research tasks. One where you say to someone, hey, we know there is a law about this, go and find it and then tell us what it says. And the other is, we don't know how a known law should apply to this. Use your analytical thinking and then map it to the facts. And finally, the unknown unknowns are, geez, what's the tax treatment of this deal in Russia? We should call Putin and find out. And so those are the four kind of maps. And I think like a lot of people who are building AI agents at the moment are trying to figure out, well, what's my AI agent doing for the user? Is it, one, capable of doing so? And two, even if it's capable of doing so, is it reliably doing it, consistently doing it? So just mapping it back to the listener's world, in case they're lawyers.
I love it. And so thinking about the Rumsfeld matrix, I've been thinking a lot about how to build this as part of legal tech tools, which of course Horace is doing, Jason is doing, and I'm doing. And of course, each of us in our own systems is cataloging all the known knowns. That is all the tasks that we already know about. And of course, a lot of those tasks are already within Sally and Soli. And then once you have those tasks, it creates a long tail. That is, there's the head of the tail that are the known things, that are the common things. These are the things that I know I do for every single legal task like this, whether it's a litigation matter or a transactional matter or a regulatory matter or an advisory matter. There are things that I as a lawyer know, and then there are things that I as a lawyer either don't know or are too uncommon to really think about, as this is the long tail. So for those known common things, let's go ahead and tag those things up. Let's go ahead and code them up so that we can be able to deterministically, reliably be able to do those tasks every single time. And then for those unknown, uncommon things, let's maybe just let the machine maybe explore that space. Let our secretary/agent be able to explore the space. Maybe we have a human in the loop to be able to then be able to maybe say, give a thumbs up or a thumbs down, much like we would give a secretary or a junior associate a thumbs up or a thumbs down, and then let the machine execute that task. So as we think about the known knowns, let's, as a human, define those goals, define those tasks, let the large language model execute the tasks, and then achieve those goals. And then, of course, for the long tail, let's have the human define what are the goals, and then let the machines explore that latent space, explore that interpolation that Jason was talking about. Maybe the human gives a thumbs up or a thumbs down, and then the machine executes the task. When people talk about agents, they often are talking about the right-hand side of the screen that I'm showing right now, but they aren't thinking about the left-hand screen. But to the end user, both sides of the screen are magic. That is both the human created symbolic agents or the LLM created agents. Those are both to the end user magical. So as we think about, let's go ahead and code up the symbolic things. And then as the large language models collect the less common things and the less known things, making them known and making them more common, let's move that line to the right. That is, let's take the probabilistic things and move them over to the symbolic side. And then on the symbolic side, now we can get the benefits of determinism, the benefits of being able to have it reliable, and then be able to just continue moving this orange line, if you're seeing it on YouTube, move it more away from the probabilistic side to the deterministic side. What do you think about that, Jason and Horace?
I think so. I think this is our lived experience. We just don't perceive it, right? So what happens is, so you're in a business, and this is the path to scale, basically, right? Where you take a bunch of stuff that you do and you reduce it into the deterministic realm, you make it symbolic, and implicitly what you're doing is you're reducing the input cost for getting that thing done. And that is the path to scale, like reduced input cost per unit. And what's wild about this for me is I think we're seeing the acceleration of moving things over that fence that you're showing, right? Because what's happening, so one of the things people, I don't think they think about is that when you have better tools, you can make better tools. And it ends up being this compounding value. And what we're seeing is the ability to accelerate the process of exploring that, other parts of the latent space and move things faster into symbolic. And what shocks me is that people don't yet understand that you can just go into ChatGPT and do this right now. You can go in and you can make code right now. Now, it doesn't make it easy to run the code, and I'm excited for the point where effectively we start getting run times where we can go operative. Like that's going to be just bananas wild. But people can go create Python right now in ChatGPT. You can describe like I want to accomplish a thing, and you can get that. So if somebody can engage in the metacognitive task of unpacking, here's how I perceive a thing I'm trying to do, here's how I break it into steps, you can go the symbolic right now. And ultimately, I think what's going to happen is the tools that we have are going to get better and better at perceiving what we're trying to accomplish, matching those against known patterns, and then offering up solutions to us that's like, hey, I think this could work for you in a very and Damien, I think you're highlighting it in a very trusted and known way, because I'll be able to show you all the steps that I will take. And you're already seeing iterative precursors of that, of a form in the O1 preview models that are coming from OpenAI, where they're basically using more inference time compute to allow a bit of recursion and like let me try again. And so you're seeing just kind of the glimpses on that future now. So I'm in violent agreement, and I do not know where all this goes.
I love it, and I've also thought a lot about this is a way that on the left hand side of the pane, that is the things that are symbolic and deterministic are also explainable. We as lawyers need to show the proof. Show me the evidence to be able to back up what you're doing. Symbolic AI gives you that evidence. And what you were just saying, Jason, is having the large language models serve up the symbolic AI. This is essentially showing their work. This is showing the evidence to be able to say, hey, it looks like you want to do this thing. Here's it laid out step by step. Does this look right? And of course, then the human can say, yes, that looks exactly right. Now you've shown me evidence for this. Therefore, I can trust this system rather than the magical agent that's trying to do things that I don't know anything about. It's a black box. Horace, what do you think about this idea of taking the probabilistic and moving it over to the symbolic?
I've got two kind of contributions to that. But before I get to my pyramid contribution, I'm going to go back to the O1 comment that Jason made. The O1 model, I think, is a really interesting step. But one thing about it, I think, is holding it back from being useful for lawyers, and that is it's hiding the thinking tokens. And to Damien's point, lawyers need to be able to assess the reasoning, because if the reasoning is off, then that does not work. When you're doing maths homework, you've got to show you're working. So the move by OpenAI to hide these thinking tokens, probably so that nobody else can train the same sort of model they can, is harmful to the end user, or to this group of end users. So for anyone else who's kind of creating a thinking model that's using more inference time compute, make that visible. And then you'll probably get a lot more lawyers using it. The second comment, which is to talk about Damien's kind of moving orange line and shifting more of the unknown stuff into the repetitive known symbolic side, we kind of have an internal model that we use to think about this problem, and we're calling that the complexity pyramid. So if you map out the work that people have to do inside of organizations, and this has been happening for centuries, we all start by doing the grunt work, building the things and like really simple stuff. Like back in the old days when you're a farmer, you have to go and, toe the fields. You don't have any machinery. And then one day you have machinery, and then you just keep progressing with technology. And human labor is being applied to the more cerebral, the more complex stuff at the top of the pyramid, which continues to grow upwards. So it's not like there's a cap. But what all the software and all the technology has been doing is it's been chipping away at the bottom of the pyramid, automating this, making it easier so that humans don't have to spend time looking at those things. And for the last decade or so, one of the things that's become quite popular in legal is low-code, no-code platforms. They are really, really good at automating repetitive tasks where it's easy for someone to capture their knowledge. Large language models has made the next layer easier to capture, where you don't need to be very good at building these bots. You just have to describe the language, and the LLM can go and perform these tasks. And at some point, there's a fuzzy line between giving a prompt and it becoming an agent, but at some point it becomes an agent. And yet, I think what's happening right now is people who are building these agents, they're not going, hey, these are the easy stuff, let's move it across the line to be automated. They're going, let's address everything in the complexity pyramid, the hard stuff, the easy stuff, the middle stuff. Let's try to move everything to agents. And I think that's causing unreliable performance and harder. It's making it harder to move things across into the repetitive field or the repetitive section. Part of it is because I think people don't know the capability of agents at the moment, of large language model agents. And so they're trying everything. And it's going to be interesting as the market continues to evolve where we eventually land and kind of what is the high watermark for this generation of large language models.
I really like what you've just talked about with the complexity pyramid. And I think the temptation for legal tech entrepreneurs, especially those who aren't seeped as lawyers, that I know all three of us on this call are both have the knowledge of the lawyer realm and also the knowledge from the technology realm. But those who have more technology but almost no lawyering skills are tempted to be able to let the agents just go out and do their thing because they lack the subject matter expertise to be able to actually explore the known knowns. They don't, for them, for engineers, everything is a known unknown or an unknown unknown. So they're essentially punting by allowing the LLM agents to be able to explore the space that they lack the subject matter expertise on. So I've been thinking a lot about that, and I've been also thinking about Adam Ziegler, who was formerly Harvard and is doing some really was doing cool things with Brighter, and is really one of the best thinkers in the space. This morning I saw a LinkedIn post where he was talking about how IDEs, and for the less technical listeners, that's integrated development environments like VS Code from Microsoft and others, how large language model backed IDEs will often provide comments to the code. And the benefits of that is that putting the comments in the code is essentially teaching the user, teaching the coder why it's actually doing the things that it's doing. And Adam Ziegler made the good comment, why don't legal technology tools do the same thing? That is, as it be able to create an output, why doesn't it give the equivalent of a Microsoft Word comment to be able to say, I'm putting this provision in this contract here to avoid this risk, or I'm putting this portion of the brief in here to be able to cut the other side off at the pass in this way. So by essentially showing their work in this way, IDEs build trust. So I wonder if there's a way for legal tech to be able to take Adam Ziegler's really good advice to be able to say, let's teach the lawyers why they're doing the output, thereby both number one, showing their work in a way that O1 is not showing its work, and number two, to be able to teach the younger lawyers that subject matter expertise and make them better going forward. What do you think of that idea of being able to create comments or teachings through an IDE style commenting?
I think there are maybe 5 legal companies that are capable of doing that because only 5 of them have the content necessary to be able to provide like actually substantive comments rather than what we would call like middle of the bell curve parametric memory based guidance that doesn't really help like your top tier lawyers. It helps your common everyday man because it gives them a rationale that sounds plausible, but to your top tier lawyer, a large language model's rationale for why this provision's been inserted, I would say more than half the time, you're going to look at it and say, no, it's not. That's not why I inserted this. And you need the data. And very few companies have that.
I think that would be incredibly valuable. I think Horace is right that there is an implicit challenge in this, which is code is very functional. You're basically declaring what it is supposed to do in operation. And some of what we do when we're drafting things is for it to actually, as weird as it sounds, sometimes you want something to not work. Like you'll literally put a provision in that's like, I added some words, I don't think they do anything, and that was their purpose. It made the other side think like, oh, I got what I wanted. And well, did you? You got some words. And so there's a certain amount of kind of, I don't know, second layer of things that sometimes happen in, I would say at least more complex legal work. However, it's interesting to think about like at most, at most that's 20% of anyone's portfolio, if we're honest. At most. And I do wonder, if you basically took your agreement and you throw it into one of the generally available language models that had a big enough context window for a lot of the more basic stuff, would you get a good enough explanation of what this is doing? So like, and this is where I think it is very tempting for us to think about markets monolithically, right? Like, I need the best lawyer for everything. No, you don't. We really don't. And this is where, as buyers, by the way, I lay the blame at the consumers and the buyers. Where basically what we presume is that every piece of work that we possibly could ever do is going to need the smartest, most gifted, most trained intelligence ever, and that's just not true. Sometimes you need a limousine, rarely, and sometimes you just need a taxi to get where you're going. So that's one thing that triggers me, and I would actually be tempted to run it. I may actually, after we finish this up, I may take one of our kind of like standard agreements, throw it into one of the conventional large language models, and basically ask it to explain to me what this does. What is the purpose of this here, and see what it looks like. Horace, there's something that sits underneath the other thing that you were talking about, the complexity pyramid, that is very intriguing to me, and it's more of a generalized pattern, which is whenever there's a new technological paradigm that reflects a general purpose technology, it's like the diffusion into the market is hard because you basically have to decompose all the stuff to be able to fit it in. So one of the examples that's been used, I think repeatedly, that's a good one, is electricity. When it showed up, and we had electromotive force, so we had electrical motors. The first thing that people did was like, oh, I'm going to create a giant motor where I used to have like a steam a steam engine, and I'm going to try to shove this thing in, and it's like, oh well, this isn't all that much better. And it took a while for people to effectively decompose all of the sub processes in the factory and realize, oh, we can have localized motors that are super efficient, and now we can do all these other things. And so to your point, one of the patterns that people start with is, well, my unit of effectively intelligence application is a human who has a set of bound work that evolved over time and was never refactored into smaller subunits. This goes to what Damien is talking about. It was never refactored into smaller subunits, and so now my expectations are that I'm going to find an intelligence that I can somehow swap out for an entire human, which is nonsense, right? Like, that doesn't make any sense. And so I think there's something that sits underneath the complexity pyramid, which basically says, and I like how you're saying, we're nibbling away from the bottom, which is exactly how we should expect it to go. And it's weird to expect that magically somebody's going to take bites out of the top of the pyramid with machine intelligence sooner. Like that would not meet our expectations for just how the world works, right? So I think that was deeply resonant for me, and I think it fits into a larger pattern of general technological basic disruption of general purpose technologies.
And I think part of it is also like, if there is a technology that can go and just take a big bite out of the top, you're going to meet a lot of resistance from people. Transformation is going to kick you in the face. And that, I think, is the other side of this, because it's always people, process, technology. Now, one of the things that people have been talking about in the agent space is human in the loop. And Damien, I know you've got some thoughts about human in the loop and how that should fit as agents continue to get better as we refactor the workflows. So what do you think it's going to look like?
Yeah, I think that humans in the loop are necessary, at least in the short term, because of the lawyers needing these systems to show their work. That is, you have to have the humans in the loop to be able to give a thumbs up, to be able to say, yes, this is the way that this thing is done. But of course, much like beauty is in the eye of the beholder, a particular good legal work is in the eye of the particular lawyer. That is, what is good legal work to lawyer number one is awful legal work to lawyer number two. So I think we need humans in the loop to be able to accommodate both lawyer one and lawyer two and their disparate definitions of what is good legal work. So I think, yes, humans in the loop are necessary to accommodate human idiosyncrasies, which goes back to what Jason was talking about just a bit ago about good enough law. And the client doesn't need the Rolls Royce of things every time. Sometimes they just need a Yugo, to go back to a 1980s car, right? And this good enough revolution is something that Wired magazine had a bunch of years ago, talking about VHS versus beta, Beta was a better technology, but VHS won it out because it was good enough. Same thing with MP3s versus CDs. CDs are much better, but MP3s were good enough. Same thing with telephone cameras. An SLR is much better than a telephone camera, but the telephone camera was good enough. And now the telephone camera, of course, exceeds a lot of the SLRs. So I think this idea of good enough is not just for legal, but it's good enough for any aspect. That what is the value of the thing being provided, and what is the cost of that? And does at some point the value of the thing is good enough if it is at a lower cost? That relates to humans in the loop to be able to say there are some things that definitely need humans in the loop. Bet the company litigation, bet the company contracts, that kind of thing. You need humans in every part of the loop. But really routine legal work, maybe you can maybe reduce the number of humans in the loop, because what human lawyer number one thinks is good really versus what lawyer number two thinks is good, maybe that distinguishing doesn't matter. The client doesn't want to pay for the arguments between lawyer one and lawyer two. The bot doing things is maybe just good enough. And the last thing I want to add is that to build upon what Jason was talking about earlier, talking about the unenforceable thing, that maybe you include the thing in the contract that maybe doesn't matter as a horse trading exercise. John Scrutato, a really smart person that all three of us know, he really introduced that to say sometimes there's a provision in there that totally violates the law and is totally unenforceable because it violates what the U.S. law or EU law, et cetera. He said, I'll include that because then I can, if the other side wants that, what's the harm? Because there's nothing to that. So you can imagine if a naive large language model looks at that provision, it might hallucinate a reason to justify that particular provision, but it's not the real reason, because the real reason is just horse trading. So you can imagine you need a human in the loop to be able to put that comment in here saying, hey, for this deal, this is just a horse trading exercise. I got this other thing. This is a BS thing that violates EU law, will never be enforceable. That is a human known thing. That is a signal that the large language model lacks. The large language model will think it's just noise. If we are able to have the large language model suggest things that maybe are, did you mean for this contract, did you mean this is the purpose? And then the human in the loop is able to say, yes, that's exactly what I meant. Or no, I just did this as a horse trading exercise. Then that kind of did you mean LLM suggestion is maybe a good process to be able to think through what these kind of comments would look like. What do you guys think?
I have a curiosity that comes from this, which is I think you're pointing at
Please.
an interaction pattern that maybe we should start having space for, which is effectively an agent is not in the future state is not only something that goes and effectuates my will. I give it objectives and a budget of resource and it goes and does the thing. But there may be a version of it that looks like my intern who watches me do certain things and interrupts me and says, why did you do that? Take the tacit, the implicit, and make that something that is declared and explicit so that I can get smarter. And this is how humans work, right? Like for any of us who've been through any kind of guild or apprentice-based instruction, this is how it goes. You literally work, elbow to elbow with somebody else, and they do something. You're like, I don't understand why I did that. I'm like, oh, let me explain it to you. And so it'll be interesting to see how we try to get there, because one version of that looks like the observed paths model, and the other looks like a brute force. Like I look at all the things that have ever been done, and I look at their inputs and their outputs, and then I effectively try to regress and reverse engineer like why that existed by effectively a naive sense of the outputs. And what's interesting to consider is both of these could work potentially, but one, and it might be much more computationally less expensive. We may learn that it is far more effective from a total expense of the enterprise to do some things where rather than just trying to like harvest every piece of data that's ever been created and the inputs and the outputs, it is just far more effective to work our way up that complexity pyramid with a more kind of directed process. And one thing that I would offer to people who are makers of products, and this goes back to I think some of the ideas of wouldn't it be interesting if the product could express like why did we do this? Like at what point do the products that we engage become potentially effectively reasoning observation mechanisms for the businesses in which we work, right? And I think that I don't know that that will happen, but I think these are all things that potentially could happen. And the thing I would offer for anybody who's generally thinking about designing around the future is presume that human time, attention, and cognition are going to be scarce, and machine intelligence is going to be plentiful and highly available. And so, if you start kind of designing a future state with the human cognition being your fundamental time, attention, cognition being your constraint, and you're going to effectively have this resource rich pool of machine intelligence, what might you do to create the most leverage on the thing that is scarce?
I love it, and that
So,
goes to knowledge management, and to be able to say that the reason that we don't have knowledge management historically is because humans are too busy to be able to do this work, and this is a way that we can maybe let the machine intelligence be able to do things that humans are too busy to do, and we can easily give a thumbs up or no thumbs up at all, and just let the machine do it. Horace, what do you think?
well, I was going to say that what you're talking about, Jason and Damien, is you're trying to capture human expertise. You're trying to capture process into some sort of computational storage. At the moment, that's not easy. And I don't think there's a defined process. There's not even a defined format for how you save human expertise. One way that some people have been trying to do that is by giving memory to the language models, so that, like, whenever you've done something, here's a memory of a similar event in the past. Therefore, there's your few shot prompt. Follow this style. I don't think that is a scalable solution. I think it's going to lose a lot of nuance, and also it really doesn't capture reasoning or expertise at all. The other way of doing it is to do reinforcement learning through human feedback. Again, I don't know if we're going to have enough data to be able to do that. And so it really needs a new modality of capturing that expertise. I really like your idea, Jason, of a machine that interrupts and says, hey, why did you do that? And then forcing a human to give a reason. I think humans are going to hate giving reasons because they're going to say, I don't have any time. So I like Damien's twist on that, which is let the machine guess the feedback and the human just goes, yeah, you're right, or no, you're wrong. Provided you capture enough of this, then I think at some point that higher layer of the complexity pyramid opens up and the machines can now actually follow reasoning. It's just right now we haven't captured this and we haven't got the format to capture this. So there's, I'm sure, brainiacs out there doing their PhDs right now who are coming up with a system to capture this. And if they do, I think that's the next big floodgate that's going to open.
There's a way to be able to capture legal works, that is, whether it's processes or legal insights or legal propositions. Of course, Sally and Soli are a way to be able to put in on the symbolic side what is otherwise conceptual in our mind. So there's a lot of good thinkers on the knowledge graph space, and Sally, Soli are knowledge graphs, and knowledge graphs are nodes and edges. Think of nodes like nouns, and think of edges like verbs. So associate is a noun. Drafts is a verb, contract is a noun. So it's essentially creating triples of all the work that's done. Associate drafts contract, partner reviews draft, secretary files motion. So each of these things, if you can then put into the symbolic side what the processes are for any legal work, you can then take from the abstract and put into the concrete, what in code, what is actually being done. And so you can imagine the large language models extracting associate from the text, and then extracting drafts from the text, and then extracting contract from the text, and then being able to say, hey, is this a part where an associate drafted a contract? And you as a user can say, yes, turns out it is. And now the large language model can traverse that graph, saying, show me all the times where associate drafted a contract that involved a force majeure clause for a Chinese contract. Each one of the things I just mentioned, associate, draft, contract, China, force majeure, those are all Sally tags. So now that I've extracted those Sally tags and I've extracted the traversing of that graph, now the large language model can suggest all of the knowledge graph to be able to take from the abstract and put it into the concrete.
We're building another tool for agents, right? Like if we have knowledge graphs like this, then agents can traverse it. Just to share like one idea that we had, which we have not executed on, it is to take long contracts with these kind of overlapping complex provisions, put it through a large language model and say, deconstruct that into the simplest possible statements. And so one complex clause becomes 20 bullet points of A does this, B does this, etc. Now you have a knowledge graph that's easy to map out. We found it was pretty unreliable, but that was with GPT 3.5. We haven't done this since then. So maybe you can do it now. So I think giving tools like this to a large language model is maybe one way that agents get smarter, maybe. But Jason, I interrupted you. You were about to say something.
So I am very bullish on knowledge graphs generally and specifically for the legal space for a few reasons. One, what Damien just described is a projection of how humans associate the elements that actually create meaning, right? So if you think about how literally how our neurological processing works, it's much closer to what Damien described, where you effectively have all these nodes that have relationships. So I subscribe to the theory that is probably a better, if you want to understand how a human who reasons through something is making decisions, being able to observe the knowledge graph is probably in many instances more powerful and more information dense from a reasoning standpoint than like the long prosaic things that we have, which points to a couple other things that I think are very interesting. So there's a technology that Microsoft's been working on called GraphRag. And what it does is it functionally tries to reduce, kind of prose into exactly the kinds of structures that Damon is talking about. And one of the things that you find when you do that is you get better precision and recall on the information in that. Because what you're doing is you're creating a more effectively terse and succinct information dense information construct that can be interrogated in very precise ways, very efficiently. We don't need to get into the math, but basically it would be too computationally expensive to do these things as a bunch of like table joins. Like it just won't work. And so one of the things that you see is the combination of creating a more powerful semantic memory for a kind of a defined memory space plus the LLMs gives you something that is incredibly powerful. And so I think that like what we're talking about is probably going to slide by most people because we're like nerding out pretty hardcore. But I do think that there is something incredibly powerful, and if we can get people to effectively project more of their kind of graph view on things, I think it probably accelerates the process of making machine intelligence smarter because it is a more authentic projection of how we are associating things and creating effectively relationships that express insight and value that are not necessarily easy to mine from just kind of flat prose. So I'm very bullish on the concepts that y'all are talking about here.
I love it. And knowing that I have 4 minutes before I need to jump and lead a presentation to a bunch of Indiana lawyers, maybe my last comment and my closing comment before I leave it to Jason and Horace to give their closing comments. I 100% agree with Jason. And it really relates to a cartoon that is both funny and profound in our large language model future. And the cartoon says, on the left-hand side, it says, look, I'm a sender of an email. I took this bullet point, turned it into an email I pretend I wrote. And then the recipient says, look, I took this email, turned it into a bullet point I pretend I read. So the idea is if it started as a bullet point and if it ended as a bullet point, what's the point of the email in the middle? Because there could be 1,000 versions of that email. There could be 1,000,000 versions of that email. And so what Jason just said is the bullet points are an information dense way to express that email. So I think as we move forward, I think we are going to essentially compress the knowledge space into those bullet points. And those bullet points are Sally solely tags. And that is both the edges and the nodes, lawyer, drafts, contract. If you then compress that email into those bullet points, that is going to be the function of the smartest people. Because the smartest people I know are not sending emails that are 5 pages long. The smartest people I know condense that into 3 bullet points saying, I want you to do 1, 2, and 3. The value going forward is going to be in the bullet point, not in the largeness. So as we close, Jason and Horace, what do you think?
I'm going to give Jason the last word. So I'm going to give my thoughts now. And that is the reason why, and I'll map it back to agents in a second. The reason why that fluffy email is important is because that mimics human behavior and human expectations. And so when we're building agents, I think there's an element of we have to make sure these match what humans want them to do. There was a while ago, I saw they were trying to get AI to design cars, like the chassis for a car. And when they gave it to the AI to develop a really strong chassis, it came back with this almost an insectoid style webbing instead of like a normal car chassis. That's because it's not constrained by humans, but humans would never ride in that car. So you have to make sure there's a relationship mapping between humans and AI agents. Jason, final word is yours. Please close us out.
I think you just pointed to something very powerful, which is the rate of diffusion of technology is probably directly correlated to human comfort with it. So that's interesting. And my general observation is that the organizations that get comfortable figuring out where to let agents play sooner are going to have that compounding advantage that I referred to. And ultimately, they're going to figure out a different leverage function on human intelligence that makes them incredibly competitive. And it's going to be interesting to see the experiments that people run to figure that out. Because I think there's like an exponential future waiting, and it's going to be exciting. So let's go play.
I think that is an excellent way to close out this episode. Jason, Horace, I think this is one of my favorite episodes. I loved geeking out with you. Thank you so much for geeking out with us.
Likewise.
Thanks, y'all.
Bye, everyone.
Thanks, everyone.